Hello everyone. Now that we have some basics of classes and objects under our belt, I'd like to talk about a class that comes along with Java called a Hashmap class. This class is an example of a specific kind of class called a container class, and we use container classes to store other objects in an organized way. Now, of course, there's already one way that we're used to storing objects, a large collection of objects, and that's in an array. So if I go back to this exercise that we had last time with the student class, the last thing you had to do was make an array of students, right? So here I'm totally stealing this example from Josh, who made a perfect example for this session, because he made 20 different students with different first names, and that'll be nice for us. Actually, you could have done this exercise faster just by doing loops, because I didn't really care what the names were. But anyway, thank you, Josh. This is perfect. Okay. Now you might recognize some of these students. They're probably not all the class years that it says they are and the ages that they say they are, but this is fine for now. Okay. So I have this array of students. Now let's say I'm not really sure who's in that array, and I may not know all the information about them. So I may not actually know that Jamal Murray is a junior, for example, or if he's even in the list at all. So let me actually try to find him and then extract that information. So what I'm going to have to do to find an object in an array with particular properties, with a particular set of properties, I'm actually going to have to loop through that array. So let's look at this. So let's actually now say that Juju Smith was the one that I wanted to find. So I would start at index 0 and I would say, okay, is that name equal to Juju Smith in that object? No. Keep going, keep going. I get up to index 7. Is Christian McCaffrey equal to Juju Smith? No. Then finally I get to index 8 and I say, okay, does this object have the name Juju Smith? And yes, so I finally found him. So that's the object that I'm looking for. Alright, so we're just going to have to make some kind of loop to loop through these things. Now let me make a general purpose method that certainly not going to depend on a particular object, so it'll be a class-wide thing. So we'll make a method that belongs to a class, and remember for that we make it a static method. Okay, so I'll say public static student find student by name. Okay, so the first parameter is going to be the name, and we're also going to pass along the array of students that we're looking for. I'll call it slist. Okay. Now remember, before we go any further, it's good to set our intention with the method. Kill two birds with one stone, because we're actually going to not only create the documentation so other people will eventually know what we did, we'll also say what is it that we're trying to do for ourselves as we write this. Okay, so what we want to do is look up a student by name in an array and return the object for that student. So we specify their full name as a string. Then we have an array of student objects. And what we're going to return is if a student with this name exists in the array, return that object. Okay, but it's possible that I might ask for a student that's not there. In that case, I will just return null. All right, so the best I can do is start at the left and go right and look through everything. So I'm just going to have to make a loop. So let me initialize the variable that will hold the result. So I'll say student to return equals null. And then at the end, I'll return the student. So if I don't find them, this is just going to say null, and that's going to be fine, because that's what we want to do if we don't find them. Okay, but now let's make a loop. So a for loop is a pretty natural loop if we're going to loop through all the elements of an array. So we say for int I equals 0, I is less than slist.length, I++. Okay, so now what we should do is actually figure out, well, what is the name of the student at index I in this array? So we're going to go through every student. And this particular student, we'll say name I is equal to, now remember, we defined this method last time called getFullName, which returns the first name plus a space plus a last name. So we're going to use this method to look them up by their full name. So I'll just say, okay, well, this slist at index I get full name. So call that method on the object at index I. And store it in a string. Sorry, I put their student by accident. So string is what we're comparing to here. Okay, now, but I want to see, does this string actually match this string? And we have to be a little careful with strings. We have to use something called a comparator, which I'll talk about more in a week or two. But so the syntax is if name.compare to name I equals 0. So this will be true if and only if these two strings have the exact same characters. So if the name at this particular index is equal to the name that I'm searching for, then awesome, I found the student. So I could say to return equals the slist at index I. Otherwise, I may go through the whole loop and never find them, so this if statement will never be true, and I'll just return null, which is the thing I said it would be otherwise. Okay, now just one quick thing to make this a little more efficient. This is going to go through the whole list no matter what. Even if I find Juju Smith at index 8, or wherever he was, it's still going to go through all 20 elements. So let me actually have a Boolean that says, did I find it yet? So Boolean found equals false. And if I find them, I can say found equals true. And now I'll add something to the for loop stopping condition. I'll say, if we're still within the bounds of the array and we haven't found the person yet, then continue going through the loop. Okay, so that'll make it just a little more efficient. Okay, let's test this out real quick. So let's say I wanted to look up Juju Smith. So we'll say student Juju equals student class dot find student by name. So we'll say Juju Smith. So that's the name we're searching for. And now we also have to pass along the list of students, right? Which we call S here. So we pass along the thing we're searching for and then the list. So let's see if we actually got an object back. So if we go to print out Juju, it's going to call this toString method. So it'll print out their name, their age, and their class year. So if he was actually there, we should see all that information. So I'll say system.out.println Juju. So let's try this. Nice. Okay. So I clearly got the object back. I have all the information I need now. Okay, well, what about me? Am I on the list? I don't know. I remember this is all on the list. I want to try to look through it myself, so I'm going to have the computer do that for me. So if I say student Chris equals student.find student by name, Chris Traley, am I there? Let's see. Okay, so let's run this. Okay, so this returned null. So that's exactly what we wanted. Very good. All right, so we just made this method that loops through everything until you find it, and then it returns it, and that's it. But this is a little bit annoying for a couple reasons. Number one, it's inefficient because we have to look through the entire list. I mean, 20 is okay for a computer, but what if I'm at a huge state school and I have 20,000 or 40,000? Then I'm going to have to look through 40,000 things every time I want to find a single student. So that's not very efficient. On average, if there are 40,000 students, I would have to go halfway through. So on average, I'd be searching through 20,000 for 40,000, but still, that's pretty bad. And we're going to be searching through songs later when we do the Shazam thing. And there may be millions of songs, right? I don't want to search through millions of songs every time I want to find just a single song. That's going to be very slow. Okay, the other reason is I have this piece of information that I can search by, but I have to make a loop and sort of manually pull that out and compare it, right? And I want to do something a little more natural where instead of looking these up by their indices, maybe I'll look them up by their name. So the fact that Juju Smith is at index 8 isn't really super relevant to me for the task that I'm doing. I really just want to know that he's Juju Smith, right? So why don't I just try to look him up by his first name? So instead of saying index 8, I'm just going to say Juju and look him up. Same thing with John. I'm going to look up John just by specifying the first name John. I'm going to look up Charles Barkley by specifying the first name Charles. All right. So that's going to be a lot easier. And now we don't even really care what order they're in, right? I mean, before we were pretty obsessed with the indices, but I could easily switch John with Charles and nobody would know the difference, right? I'm just looking up things by their name. Whoops, I went away there. So now I can think of this more as an unordered collection, which is actually nice for this purpose because I don't want to impose an order. The order is arbitrary. The order is it's just an artifact of the fact that we're using an array. The order was kind of imposed on us. So this is what a hash map does. It allows us to look up something by a key. So this is what you're looking up by. And then it gives us back a value. So here the key is the first name, and the value is the object corresponding to that first name. So now let's look at the syntax for how to use a hash map to do this. So the hash map is an object, or the hash map is a class itself, so we're going to have to make an object of type hash map. Now we have to specify these two pieces of information, which is what are the types of the key. So we're going to look here, we're going to look this up by the name, so that's a string, the first name. And what is it that we get back? The value. And the syntax is this goes in angle brackets here. So we have the key type and then the value type. And I'll call this student map. Okay, but that's not quite enough because it tells us variable student map is not used and it's also not initialized. So we have to actually call the constructor of the hash map. And actually all you need there is the empty angle brackets. And when you call it this way, it's just going to make an empty hash map. So we actually have to fill it up. So let's copy over the data from the array that we made to this hash map. So I'll say for int I equals 0, I is less than student map.length, I plus plus. And, oops, sorry, less than s.length, because we're going to copy it over from the array. So now I can say student map.put. Okay, so this is the syntax. You're going to put the key in the value. So add an entry with lookup information key and a particular value that gets sent back. Okay, so I want to look them up by their first name. So I'm going to have to, because the first name for an object is actually a private variable, I'm going to have to make a getter for the first name. So I'll say public string get first name, return first name. Okay, so the key is the first name. So I'll say s@indexi.get first name. Cool. Now the value is the object. So it's actually just s@indexi. All right, so then I added to the collection by saying put key student. So key value pair there. All right, so this is how I make the hash map. And as long as I don't have two students with the first name, this should add 20 different things. So let's just check the size first. So we'll say student map, and then there's a method called size in Hashmap, which tells us the size of a particular Hashmap object. Okay, cool. So here I see I have 20. Because again, Josh did a lot of work and he gave them 20 unique names. All right. So what now? Well, let's see if I can do that same task that I did before, where I actually, once I've initialized this and put everything in my collection, let's see if I can find a student with a particular name. So let's try Juju again. So I'll say student Juju equals student map.get Juju. And let's print them out. System.out.println Juju. Let's run it. Awesome. So that worked. So see how much easier this is? It's only one line of code that I have to write. Once I filled this in, and I can do that at the beginning, it's just a single line of code. I don't have to go through this whole method and loop. And this is actually much more efficient. In 371, we'll talk about how this actually works behind the scenes, how hashing works. It's called hashing. This is how we look things up quickly. This is actually where hashtag comes from as well, by the way, because you got millions of hashtags out there and you want to be able to quickly find the tweets that are associated to a hashtag. Okay, so that's how you find something and look it up. Now actually, okay, and again, let's test this to see what if I try to look up Chris. There's no Chris in the list. So I'll try to say student Chris equals student map.get Chris. And let's print out system.out.println Chris. No, great. So this has the exact same behavior as the method that we defined. Now, of course, I can add a Chris if I want to. I can say student map.put Chris new student. And what am I passing along there to constructor? It's age, first name, last name, class year. So we'll say 31 Chris Traley, super senior. Okay. And what is it complaining? Whoop, of course I need a semicolon. All right. So I can do that, and I can actually make a new object on the fly, and now it's going to be able to find it. I can also overwrite objects, so I can say student map.put Juju new student. Now we'll make him 50. And so we'll have all the other same information, I guess. So we'll say he's a sophomore. But now I'm gonna make a new object that has a different age. And so that's going to overwrite, actually it's going to find where Juju is in the collection, and it's going to overwrite it with a new value. Okay. So there we go. So that's the basics of how to use the hash map. Now, okay, so we're going to stop here and do just a quick exercise.